So here, this is just a quick review of what I mentioned last time, like some definitions of numbers that are being used here implicitly and maybe were not explicitly stated before. Yeah, so usually we are going to work in this course, we are going to work with the largest set of numbers is real numbers. And then the first numbers that we will see are the integers, right? 0, 1, 2, 3, 4. And then we have the negative ones, -1, -2, and so forth. And then we have the fractions that are one integer divided by another one, like non-zero integer. So always remember that you cannot divide by 0. And then they're also called rational numbers. And then the other numbers that we have are those that cannot be expressed as a fraction, like as a division of two integers. And surprisingly, there are way more irrational numbers than rational ones. To actually show this, it's not that simple, but the math major, we used to make a joke about this. We would say like, yeah, because in the real world, you have way more irrational people than rational. So the same with numbers. This is how we always remember. Like always remember, there are more irrationals than rationals. But like we are not going to have to deal with whether this number is rational or irrational, right, in this course. But just to let you know, and then the union of rationals and irrationals will give you all the real numbers. Okay, and then I linked to this. I watched the Khan Academy video and I thought it was kind of cool. Like it was explaining different types of numbers. So, and then the next page, we have what we call, prime numbers. Yeah, prime numbers are what we call, you all know prime numbers. It's like 1, 2, 3, 5, 7, 11, 13, and 17, I think, 19, and so on, right? And these are numbers that can only be divided by themselves completely or by the number 1. 0 is not a prime number, right? Because 0 cannot be divided by itself. We can divide by 1, yeah. So I don't know. The first prime number, so 1, 2, 3, 5, 7, 11, and so on. And then the ones that are not the prime numbers, I think we call them composite numbers. I'm not sure actually, because I never usually use that word. But for example, number 6 is not a prime number because it can be divided by 6, by 1, but it can also be divided by 2 and 3. Why is this important is because we can factor a number, right? So when we say factor 16 into just prime number decomposition, it means we are going to write 16 as a product of prime numbers. So 16 is 4 times 4, and then each 4 is 2 times 2. So you're going to have 2 times 2 times 2 times 2, right? So multiply by 2 4 times. So you can also write it as 2 to the power of 4. You can factor 6 as 2 times 3, right? Like that. Why is this important? Is because then we're going to talk about factoring polynomials. So it's the same idea. It's like how can we break down a larger polynomial into the product of smaller polynomials that cannot be broken down anymore, like further. So if you imagine like, okay, if you can factor something big into smaller parts with numbers, you can do that with polynomials too, like just kind of like an extension of the same concept. And then the last definition that we might need soon is called domain. Domain is the set of numbers that can be accepted for x in that expression or equation. So basically, the two things you need to check is you can never divide by 0, and you cannot have square roots of negative numbers. Those are the two rules you have to check. Yeah. So if inside the square root you have x, for example, then x has to be greater or equal than 0. So that's what we are going to call domain. Because I think in your final project, you have to draw like graphs of functions. And then for every graph, we will also ask you to say, what's the domain of this function?